Assalamualaikum, a very good day. Today, my friends and I will be presenting about a group project for course Discrete Structures CSC510. These are our team members. The first one is me. My name is Muhammad HARIZ bin Muhammad ZAKI. The second one is Muhammad IZZUDDIN bin HISHAMUDDIN. The third one is Muhammad SHAHRUL Shah bin MISNAN. And the fourth one is Muhammad HAZIQ bin HASNUL. Now, let's go to the background. Relations are a basic concept used in computer science and mathematical studies. They can be used as the basis for different applied fields. Some include graph theory, database administration, and artificial intelligence, among others. However, the relationship between the elements in the set can also be explained based on the relation, and the relationship between the two sets follows the definition of the Cartesian products. It's important to have an understanding of the properties associated with transitivity, symmetry, and reflexive properties for the best use of relations concept. Specific properties have to be satisfied for a successful application. Among these are order relation properties, in which the reflexive and transitive properties have to be satisfied, and equivalential relation properties, in which case reflexive, symmetric, and transitive properties have to be satisfied. The efficiency of mathematical operations could be greatly enhanced in one significant area, that of computer program development. Analyzing, determining, and verifying the characteristic of a relation can sometimes be a tiresome job that results in human errors, especially when dealing with large amounts of data and sophisticated relationship set. The process of decision making, especially in application areas like data normalization, networking, and intelligence, and artificial intelligence, could possibly be affected due to computational complexities. A relation is reflexive, symmetric, and transitive when it follows all three properties. But to check whether a relation falls in those categories and to determine the necessary closures to make the relation properties comply, if it doesn't satisfy the reflexive, symmetric, and transitive properties, a proper and automated method must be used. Constructing a program that performs these processes provides a means of practically verifying relations and determining their closures. This program saves not only time but also yields accurate results as expected in most computational and mathematical areas of study.
Hello, this is the flowchart of our system. First, the process begins at the start symbol, which indicates that the program is ready to run. Next, the system moves to the input data, where the user enters the set elements and relation. For example, pairs like 1, comma 1. This step represents reading and storing the user's input. After the input is received, the program parses the relation. This means the system processes the input text, separates each ordered pair, and stores them in a structured format so the program can analyze the relation correctly. The system then checks the reflexive property. At this step, the program verifies whether every element in the set is related to itself. If this condition is satisfied, the program proceeds to the next check. Next, the system checks the symmetric property. This means that if a pair A, comma B exists in a relation, the system checks whether B, comma A also exists. After that, the system checks the transitive property. Here, the program verifies that if A, comma B and B, comma C exist in a relation, then A, comma C must also exist. If any of these properties are not satisfied, the program computes the missing closures, which may include a reflexive, symmetric, and transitive closure. This step ensures that the relation can be completed to satisfy the required properties. Once all checks and calculations are completed, the system displays the output results, including which properties are satisfied and the corresponding closures. After displaying the results, the system enters a wait for user action state. At this point, the user can choose to search again, reset the input, or close the program. Finally, If the user chooses to close the program, the flow end reaches the end symbol, indicating that the program has terminated.
Assalamualaikum, my name is MOHD and I'll be showing you guys the interface system. For this one, there is two. There is before and after, which is before we haven't touched the system yet, and then the after will be showing the output. And I'll be showing you the system. Hello, and this is our system. It's a relation properties checker, which is very simple for the design, and for the enter relation will be here to input, and then there will be a check properties and the clear button for the things. And I'll be showing you the input for now, which I have a sample for it. For this one, I give this. We'll be checking if this have a reflexive or symmetric or transitive, which is not, because none of them have the properties for it. How about we try another else? Let us try this one, and it will show you the symmetric, and the closure for it will be 1 1 1 2 2 1 2 2, or for the reflexive one is 1 1 1 2 2 1 or 2 2. And we're going to try another input, which is and it will show you for it is only transitive. Yes, and that's all for me. I'll be passing out to my next member.
Okay, next for result of analysis. First, the system checks for reflexivity. A relation is reflexive if every element is related to itself. Here, we have 1 and 1 in bracket and 2 and 2 in bracket, but 3 and 3 is missing, so the relation is not reflexive. Next, the system checks for symmetry. A relation is symmetry if for every pair, like A and B, the reverse pair to be B and A also exists. And for example, 2 and 3 in bracket is in the relation but 3 and 2 is missing. This is also like 1 and 2 in bracket exists but 2 and 1 is missing. Therefore, the relation is not symmetric. Then, the system checks for transitivity. A relation is transitive if whenever A and B and also B and C exist, but A and C also exist. Like here, for example, we have 1 and 2, and we have 2 and 3 in bracket, and the pair 1 and 2 is also in the relation. All other transitive requirements are already satisfied, so the relation is transitive. Based on this analysis, the system generates the closures. Transitive closure remains the same since it is already transitive. For symmetric closures adds the missing reverse pair, like 3 and 2, 2 and 1, and 3 and 1. So, reflexive closures adds the missing self pair to be 3 and 3 in bracket. So this demonstrates how the system can analyze a relation and automatically generate accurate closures, reducing manual errors and saving time. So this is for result of analysis. In conclusion, relation properties checker. For this project, our group focused on using the properties of relations, uh, specific on reflexive, symmetric, and transitive properties. A relation is considered an equivalence relation only if it satisfies
all three of these properties. Because of this, checking relation properties accurately is very important, especially when dealing with complex data. And to address this, we developed an automated relation analysis program. The program automatically checks whether a relation is reflexive, symmetric, and transitive, and it also computes the necessary closures. One of the key advantages of our program is efficiency and accuracy. So, relation properties checker, uh, um, compared to manual analysis, the program reduces time and effort and minimize human errors. So, this project shows how automation can simplify relation analysis and make it more reliable for both academic and practical applications. Thank you. This is for conclusion.